Let's start with a bombshell. Light skin might only be about 3,000 years old, not 10,000, not since the dawn of humanity, just 3,000. That means Cleopatra didn't have light skin, neither did the first Greek or Roman, and early humans in Europe? Surprisingly dark-skinned. This isn't speculation, it's what the latest genetic science is telling us. So how is this possible? Let's go back to the beginning. All humans originally had dark skin. Why? Because our earliest ancestors evolved in Africa under the scorching equatorial sun. Melanin, the pigment that darkens skin, was critical. It protected us from ultraviolet radiation, which can damage DNA and deplete folate, a nutrient essential for reproduction. Dark skin was a survival tool. It wasn't a cultural choice, it was biology. So then, what changed? As some humans began migrating out of Africa, into Europe, Central Asia, and the Arctic, they faced new challenges. Less sun, shorter days, colder climates. In these low UV environments, the human body needed a better way to produce vitamin D. See, our skin makes vitamin D when sunlight hits it, but too much melanin blocks UV rays. In places where sunlight was weak, dark skin became a disadvantage. Over thousands of years, natural selection favored people with mutations for lighter skin, because they could absorb more sunlight and stay healthier in those environments. But here's the kicker. Recent genetic research shows that these light skin mutations didn't become widespread in Europe until just 3,000 to 5,000 years ago. That's thousands of years after humans had already been living in Europe. Yes, you heard that right. Early European farmers and hunter-gatherers were dark-skinned. Scientists analyzed DNA from ancient skeletons found across Europe. What they found stunned the scientific community. Many early Europeans had blue eyes and dark skin. That's a combination we rarely imagine today. So where did light skin come from? It's believed to be linked to three major genetic mutations, SLC24A5, SLC45A2, and HERC2/OCA2, which also affects eye color. These mutations likely originated in the Middle East and the Caucasus region, not in Europe itself. As waves of Indo-European migrants, steppe herders from what is now Ukraine and southern Russia, pushed into Europe during the Bronze Age, they brought these mutations with them. This was the same period that gave rise to many modern European languages and cultures. Within a few thousand years, those light-skinned genes became dominant, but again, this only happened recently. Let's put this into context. The pyramids of Egypt were already built before most Europeans had light skin. Stonehenge predated widespread light skin in Britain. Even the earliest written alphabets may have existed before pale skin was common. So if skin color is so recent, why is it still so emotionally charged today? That's where things get complicated. Throughout history, skin color has been tied to social hierarchies. Colonial powers used it to justify oppression. Racial categories were invented, not by nature, but by empires. But science is now correcting that story. It tells us that skin color is one of the most superficial traits we have. It's like eye color, or hair texture. Just a few tiny mutations out of 3 billion DNA base pairs. In fact, two people from different races can be genetically more similar than two people from the same racial group. The deeper you look into genetics, the blurrier race becomes. Skin color doesn't actually tell us where you're from. Instead, it tells us where your ancestors adapted to survive. Now let's zoom in on the Philippines and other tropical regions for a moment. In these areas, the environment selected for darker skin to protect against sun damage. But even there you'll notice variations in tone, because humans have always moved, intermarried, and adapted. This is where another surprise comes in. Many Southeast Asians, South Asians, and Oceanic peoples actually have genes similar to ancient Denisovans, an extinct human species. These ancient interbreeding events also influenced pigmentation. So even the concept of dark skin is, pretty diverse. And what about East Asians? Interestingly, East Asians evolved different genetic mutations for lighter skin, not the same ones found in Europeans. That's called convergent evolution. When different populations, evolve similar traits in different ways. So, next time someone says skin color is biological, just remember, yes, it's biological, but not racial. It's a response to sunlight, not a measure of superiority. Now, let's return to the 3,000-year timeline. If light skin is this recent, what does that mean for the way we teach history? What does it say about our assumptions when watching movies, reading textbooks, or, just imagining our ancestors? It means we've been getting a lot of things wrong. The ancient world was more colorful than we think. The further we dig into history and DNA, the more we find that people of different shades, backgrounds, and languages were always on the move, always mixing, always changing. And we still are. So what can we take away from all this? Skin color is not fixed, it evolved quickly. We are all African at our genetic core. Race is a social story, not a scientific one. The truth? Our differences are beautiful, but our similarities run deeper than our skin. We are all human, all descended from the same roots, and we are still evolving, together.